Hi everyone, in this video we are going to see some problems based on the fourth model phase plane method. So here using isoplane method to draw the phase trajectory, they are given dx square by dt square plus 0.6 dx by dt plus x equal to 0. Here x equal to 1 and dx by dt means this is x2, right? This is x differentiated, you will get the second variable x1, x2. Initial conditions they have given. Consider the given equation. Put here first variable y1 and y2 here reverse. If they give in the problem they have given here differentiation of x term. So here you have to take the variables x is equal to y1 and this is y2 and this is y dot reverse. So previously you have studied what y d square y by dt square dy by dt and y. So y is equal to what x1. But here exact reverse variables you have to take. Here they have taken x dx dx square x, okay, differentiation of x. So here x is equal to y1 and this is y2 and this is y dot, right? So here take the variables and substitute in the equation y1 dot and y2 dot from the given equation. You will get this equation. So slope is equal to what? dx2 by d2 dx2 by dx1. Here reverse dy2 by dy1. You will get this slope. Therefore here they have given y1 and y2, that is x1 and x2 value 1, 0 they have given, right? So substitute here, you will get m from this to this value. So substitute different value of m and substitute different value of m. Here you will get isoplane and theta is equal to tan inverse of m. Draw in this graph. Okay. So this is the what? Trajectory phase plane portrait. Okay. Next, draw the phase plane trajectory for the following equation using isoplane method. They are given this equation. Zeta is given 0.5 and omega is equal to 1. Okay. So here substitute here zeta value, omega value. Okay, and initial point is 0 and x. So initial x is 0 and differentiation of that is x2. Okay, that is 6. x1 is 0, x2 is dx x1 dot, right? That is 6. See here, x is 6. Next differentiation of that is 0. y1 and y2 like this. Okay, that is nothing but x1 and x2. See here, substitute here values. You will get this equation x double dot, x dot and x. See here, substitute x is equal to y1, y2 and this is y2 dot. So from the given equation, write the y2 dot. Okay. Exactly x ಇದ್ದಲ್ಲಿ y replace ಮಾಡೋದು ಅಷ್ಟೇ, ರಿವರ್ಸ್ ಆರ್ಡರ್ ತಗೊಂಡ್ರೆ. ಪ್ರಿವಿಯಸ್ಲಿ y equal to x ತಗೋತಿದ್ವಿ, ಇಲ್ಲಿ x is equal to y ತಗೋಬೇಕಷ್ಟೇ. ಸೊ ಫಸ್ಟ್ ವೇರಿಯೇಬಲ್ x ಅಂದ್ರೆ ಏನಿಲ್ಲಿ y1. ಫಸ್ಟ್ ವೇರಿಯೇಬಲ್ y1 is equal to x. Second variable y2 is equal to x dot. So this is y1 dot is equal to what? y2. So y2 dot is equal to from the given equation. So you will get this equation. M is equal to second differentiation divided by first differentiation term. You will get this equation. Okay. Okay. Therefore substitute here initial value y1 and y2. Here you will get m range is from 2 to 2. Okay. So substitute here. See here. Okay. M is equal to this one. Y1, y2 they have given. Substitute here value. So m is equal to up to this value you have to take. Substitute here m is equal to 1, m is equal to 2 in that equation and you will get y2 values and theta values. Okay. So this is the what graph of that with respect to that angle. Okay. These are the slopes m1, m2, m3 angle, phase plane. In the phase plane this is phase portrait, that is trajectory. Okay. So this is one more type of problem. Only two type problems. They may ask singular points or they may ask a slope. That is isoplane method. Okay. So here find out the singular points means they have given equations. Okay. See here x dot x double dot is there. Okay. So first variable is what? X. Okay. Here take y1 is equal to x, y2 is equal to x dot, and this is y2 dot. Right. So y2 is equal to what? y1 dot. y2 dot is equal to from the given equation. See here in this equation find the singular points. Substitute here y1, y2, y1 dot, y2 dot. See dy2 by dy1. This is slope m is equal to. So in this equation, see here the given equation. take Laplace inverse here, x of s, s square, sorry, this is x dot, s into x of s, and this is s square into x of s. X of s common here, right? S square plus 0.5s plus 2 is equal to what? 0. Okay, so this is what equation. Find the roots of this equation. From the, use the calculator, find the roots of this equation. You will get minus 0.25 plus or minus j 1.319. So plot this poles, show the poles in the graph. See, minus 0.25 means real value, plus or minus means j value. This is imaginary value. Okay, so place it in the graph here. Minus 0.25 here left side, and plus or minus j 1.3 1.39. Okay, so the poles are exist at the left side of the graph, and the system is what? Left side means stable. So for this stable system, draw here phase plane portrait. Okay, see the theory part. Okay, the roots are left side. How is the graph? Roots are right side. How is the graph? Roots are placed on the imaginary axis, that is marginally stable. How is the phase plane graph? Okay, just go through the theory part. The poles are right, left on imaginary axis. Depending on that, you have to draw this graph, right? See, next is what? Y double dot, y dot, and y. Here first variable is what? X1 is equal to y, and this is x2, and this is x2 dot. Okay, so x1 dot is equal to what? X2. X2 dot is equal to, from the given equation. Okay, dx2 by dx1 very. So s square plus 3s plus 2, s is equal to minus 1 and minus 2. Both are real values. Minus 1 and minus 2 means what? Left side. Left side exists means system is stable. So for this real values roots, the graph is like this. Phase portrait graph is like this. See the theory part. Okay, similarly go through this third equation also, same procedure.